In our last installment of Girls in STEM, we were honored to have a virtual visit from Jessica Elwell in one of our STEM classes here at Green Hill.
Good morning. I'm Jessica Elwell, the Chief Operating Officer for Oxeon Energy. At Oxeon, we design, develop, and manufacture equipment and technology that produces fuels from non-fossil based sources. So we do that both here on Earth, approaching the renewable energy market, and we do it in space for fuel production off the planet. A big example of that is we have a device that's on the Perseverance rover that's currently making rocket propellant from the Mars CO2 atmosphere. So it's a pretty exciting industry that we work in, and I have responsibility over our overall operations here in North Salt Lake City.
We asked Ms Elwell if she was encouraged as a student to pursue STEM-related studies.
So I would say no. I really had a hard time paying attention in class and not speaking out of turn. So it was pretty rare that I'd get recommended for advanced classes. I had to do a lot of self-advocation in that realm to get myself into advanced math in 8th grade, to pursue some different things in high school that way. But when I got into high school, there were a few teachers that were more supportive of that path. But I was really lucky that my parents were really supportive. We didn't have boy and girl jobs in our house. My two brothers and I had the same expectations set on us. So I didn't see any career as not open to me. So as I developed more in what I thought I wanted to do when I grew up, there weren't really limiting thoughts that way.
Ms. Elwell wasn't encouraged early on to pursue the sciences at school. She talked about the lack of exposure to STEM-related careers and role models in her childhood.
Nothing. I literally knew nothing. I grew up in rural Wisconsin in the 80s, so I didn't have any exposure that was approachable. When I started learning about it was really my brother, who is about 3 years older than me. He went to engineering school, and I would get to visit him and see all these amazing opportunities he had in school. He was studying biomedical engineering. My brother Jeremy was a huge influence on it. He was very open in sharing what he was learning. He and I are still to this day very close. So it was really exciting to see that type of door open. I also had a high school teacher, Mr. LeMahieu. He was my chemistry teacher. And when I was speaking to him about where I wanted to apply for school and what I wanted to get into, he recommended that I do more research towards the engineering sciences.
We asked Ms. Elwell what she wished she would have learned before pursuing her engineering degree.
I think what I learned is that everyone has a pretty solid idea in their head of what an engineer is. When you go to school, it's really specific training. There's very specific tool sets you get. And I didn't know, when I got into my first job, I didn't really feel my fit. I could do modeling and I could do these different calculations, but I didn't feel like that was really the best application of what I could do. I wish earlier I would have learned that there are all different roles in engineering, that education and that early experience really prepared me for the job I have now, which is more on the management business side of engineering. And I think if there would have been more discussion about the different roles in engineering, where you're not just this stereotypical engineer, I think I would have developed more rapidly within my career path.
One question for Ms. Elwell was, does she offer the same advice for men and women, or does she feel it necessary to differentiate the two?
I can say for a fact that I wouldn't. I manage both males and females. In my last position, my team was 90% males. There wasn't different advice for men and women. What I think really the takeaway is that flexibility is key. You need to be taking internships and testing out these different positions so you learn what you like. You need to learn the different aspects of the jobs that inspire you and which aspects of it really drain you. You need to focus on the roles and the tasks that inspire you. So I have two kids. I have a boy and I have a girl, and I give them the exact same advice. I have them start looking at companies they admire. I have them see what types of jobs they have available and look at the requirements that they need to get those types of job and see if that interests them. And then they need to start thinking about what they could do to meet those requirements. Could they join clubs? Could they take specific classes? I really encourage younger people and students to look at taking time off of university to take a full-time internship and really immerse yourself in what you think you're going to be doing later. All of these things strengthen your path, and they help you fine tune where you best add to your teams, where you best add to the position that you have. So for me, it's really the same. I think we're leveling the playing field. I think males and females are in direct competition, which is really an exciting time.
Ms. Elwell often speaks to women in her field and serves as a role model for many female engineers. We asked if she feels that the increase of women-only conferences have been the cause or the effect of increasing women in STEM.
I think it's the cause. I think earlier, like I said, I was raised to not see these gender roles in jobs. And it wasn't that my parents said there's not gender roles. They just never presented it that way. And so it was never an issue for me. So I didn't really understand until I got further along in my career that this was a limiting factor for people, that people had been told, oh, women take this path and men take this path. And I think in not just in STEM, even in the outdoors world, in skiing and climbing and mountain biking, when you have that representation, when you have those people that you get to see that have a position you didn't even know existed before, and have those discussions with them of what they did to get there. I've found a lot of value in participating in mentorship programs and things like Women in Renewable Energy, where these discussions are open. And I'm learning that there were a lot of challenges placed before people that I didn't realize were there. So for me, right, ignorance was bliss. I didn't know that it was supposed to be harder for me. I just knew there weren't a lot of women doing what I was doing. So I think definitely open discussion. I think asking these questions, having visible role models. Like I can't imagine when I was a child and when I was in high school, if I had known women who were running companies, who were these awesome engineers doing these amazing feats, I think it would have changed the career path overall and given me a bit more base to step off of.
Samantha Osborne, from episode 1, had several questions for Ms. Elwell.
What is it like working for Oxeon and NASA?
It is nonstop. It is always a challenge. We do first of a kind builds all the time. Pretty much everything we're doing right now hasn't been done before. So it is finding failure modes before you realize them. It is building these teams we have young talent, we have people who have been in the industry for 30 plus years. It's exciting, but there's rarely like a moment of comfort where you're just, I have yet to have a day where I've been bored. That's not a word we use here, ever. I don't think ever. I don't have anyone who's bored. And so it's being able to accept that challenge is just a part of every day. We use failure investigation. That phrase is so common here, and you can't look at failure as though that's a bad thing. It turns out if you're doing experiments and everything goes right, you learn very little of how to control it, right? Like if everything goes right, you don't know what makes it go wrong. And so sometimes when you fail, you learn how to better replicate your system. You learn all these different exciting things about how to do it better. And so it's nonstop failure. That's what research is. It's awesome. I love it.
You mentioned that Oxeon offers some sort of like camps for like our age. Are we able to like partake in those?
So I do outreach programs. They're through different organizations within Utah. And what that does is it partners women with a mentorship group. What we do and what I recommend all of you, like everyone in this room, regardless of what you go into, we sponsor internships. But there are so many opportunities right now to get that type of experience. And I think that is the most critical path to take early. I did an internship for 6 months when I was in college. And I would say that was the most telling educational experience I had. It told me what I didn't want to do. It told me parts of the job I hated. Like there were parts of it where that wasn't for me. I could do it, but no, thank you. But then there were really exciting parts of it where I was like, okay, I need to get more experience in process engineering, in understanding how this overall system flows together. Because for me, that's really what excites me, that like high level, like how do we go from the incoming materials to this awesome product we have going out the end. I got to work for Mercury Marine, which maybe some of you know. We built outboard motors. And it was really exciting to, like, I'd drive down the highway and somebody'd be pulling a boat and there was a motor I made on the back, right? It was like, okay, that's cool. So I also worked as a technician on the line. As soon as I was 18, I took a manufacturing job to learn more about, what that process looked like. I think it's so important if you're going into engineering or you're going into some kind of design function, you need to understand what it takes to make things, because engineers love to make things that you can't actually build. It's like our favorite thing to do, right? Like you make this amazing design and you hand it off to someone to build and they're just like, what is this? And you're like, and you have an hour to build it. They're like, this is going to take me 3 days. I don't understand what we're doing here. So it's really important to get as much hands-on experience as you can, as much exposure as you can to the different types of engineering that you have interest in. It's really, to me, like school's obviously important. There's skill sets that you learn that they don't have time to teach you on the job. So you really need to gain that education or certification or whatever that program looks like. But really knowing what parts of a job you love before you like commit to it as a career is really important for you to guide how you want to go. And there'll be parts you hate. My dad used to say, you're not supposed to love your job all the time. That's why they pay you. So if you can get to like the 70-80%, you're crushing it.
Ms. Elwell also offered some great advice for all students getting into engineering fields, and some words of encouragement for our students at Green Hill.
So I would echo, we spoke right before class started, but I would echo what we talk about, how messing up is not a bad thing, right? Like that's the engineering design process. It is built to continue to be cyclical, right? And so it's ever changing, ever evolving, never stopping. Y'all heard that, right? And so Ms. Elwell, if you wouldn't mind speaking, maybe just to get it to their level and kind of what we're working on. It's a second year engineering and design class. Our main focus is computer modeling. And we have, basic parts. We kind of work through a SolidWorks curriculum and looking at the parts that they put out. But if you could speak to the 3D modeling piece of your job and maybe what you see in NASA and maybe even some companies, I know you've worked in the defense industry as well. So that's really fresh on their brains, probably painful on their brains to the point of how much we work on it. And so, SolidWorks curriculum, Revit, maybe AutoCAD even, any kind of 3D modeling software that you're aware of that you will use and how you implement that in the bigger picture.
Sure. So unfortunately, I'm not a mechanical engineer, so I hire people who are good at these things. So my level of understanding overall is pretty high level on this, but we follow really strict design review processes. We work through, right, you have your conceptual design, and we work very hard to identify failure modes or interferences, right? You're focused on form, fit, and function. I'm sure you guys have heard the 3 Fs if you're doing a lot with SolidWorks, looking at how everything comes together. Our focus is a lot on manufacturability. So when you're looking at those types of systems, you really need to think not only what does this look like and how does it work in the model itself. We use SolidWorks as well, as we did at the defense industry I worked in. But what does this look like when I'm actually trying to build it? So we do review processes that involve not only our design engineering team, but we also do it with technicians who will be involved for the assembly work. And a lot of times you get input there as far as if what you built is feasible to assemble, right? They'll identify interferences you never thought of because you haven't put it together yourself. And so that's a pretty interesting disconnect, in my opinion, between engineering and then actually production of the things that you're designing overall. We do usually a 3-stage. We have a conceptual phase, then we do preliminary design review, where we go through our full requirements list that drove what these models and drawings look like, and make sure that we can prove out in what our design is that we're meeting the specific requirements that were set for how we design the overall system. In the critical design review phase, that's the second major phase, that's the lockdown. Once we're through critical design, that's what we're going to build. What we drew, what we modeled, what we analyzed, that all gets locked down so that we can move forward with production. Does that answer your question, Mr. Wood?
That's perfect. Does that make sense, you all? And how we look at, so we try to talk about how we're zoomed in on one little bitty piece of the overall picture. And when you go 30,000, or in the galactic terms that you all are working with, millions of miles out, then we're still just that little piece, but it's a very viable and very important piece of the overall puzzle. If she didn't have the mechanical side of it, then she wouldn't be able to go forward with the chemical, with the civil, even probably, the actual build out process. Any other questions? I've got several. We will take all of them. Sam, go ahead. This is Sam again here on the front.
What kind of engineers do you work with on a day-to-day basis? What?
Our team is predominantly chemical engineers and material scientists. We do a lot of materials development. Later, Google solid oxide electrolyzers, and you can learn all about the different layers and fun that goes into that. We also work with mechanical engineers, focus on structural models, on our builds of our different reactors and systems. So predominantly here, mechanical, chemical, material science. As we move forward into full-scale manufacturing, we'll bring in manufacturing engineering, industrial engineering. We'll start looking into full plant design. So really in this position, I'm trying to think if there is a type of engineer we don't work with. I'm gonna say no. At my last job, I used to work in shoulder-fired weapon systems. And in that, it was predominantly mechanical engineers with a focus on design, and then manufacturing engineers, process engineers, and then one you probably don't hear much about in high school, but quality engineering. So those are the people who make sure all those designs you're drawing, all your general dimensioning and tolerancing, all actually makes sense and is something that we can make and that we're holding the product to.
We have two ROTC.
The answer is all.
We have two ROTC students that just perked up when you said shoulder fire. So they were all in right there. Off of Sam's question, that is actually what I was wanting to get into. So I look at you all as a subcontractor of a larger entity, being NASA and then defense systems previously. Speak a little bit to the kind of the globalization of your company, and how you have a representative in Houston or in Cape Canaveral or wherever you're implementing, or is it all virtual as you all speak back? And then maybe even previous placements that you, just for them to see like they could really operate and provide a skill or a service from anywhere in the world. I think that's what's unique about this career path specifically.
For sure. So before taking on a corporate executive role, I did a lot of our communication with our supply chain, which is a global supply chain. So I spent about 5 months out of 2 years in Austria working with our supply chain there. When I worked for the defense company, we were actually headquartered in Norway. So I spent a lot of time there. With the way the economy is now, it's a global economy. Since 2020, it's changed a little bit. We do a lot more virtual support, but we still do operational support of the Perseverance mission. So we have meetings probably once a week. Maybe it's every other week now, where our key technical people support the operation of the system on Mars. I've been to the Jet Propulsion Laboratory a few times while we were working on integrating our engineering models so that they could do testing there. So there is a lot of really global interaction. Now it's starting to move back to in person, which is my preference. I feel like you get a lot more done in the meetings where you know everybody's paying attention and they're not just, turning their camera off on Zoom and taking a nap. But we look at from program start to program completion. We're working with coordinating these international teams, and we have key people in our company who are responsible for specific parts of the program. There are what's called a subject matter expert. There are subject matter experts, and we make sure that we have those people working with their counterparts wherever that may be, as early in the program as possible, so that we can learn as much as we can about end use and, as I mentioned before, the whole form, fit, and function approach. But no, I think most positions I've had since working in renewable energy and in the defense space have been heavily involved on the global scale. So we do a lot of work with Europe. We have programs, all over the world where we're working with different partners. Yeah, kind of the message is the playing field is leveling, and the overall STEM community is going to become more competitive because you have a greater pool of talent to pull from, which is really exciting, in my opinion. It's driving the level up to have a greater pool of talent to fill these positions. I think really for all of you, growth comes when you allow yourself to become uncomfortable. And that's a cliche for a reason. It's 100% true. Taking on challenges that are outside of your comfort zone begins to give you new information that guides your path and the moves that you need to do to grow more quickly towards your goal. You have to identify the areas you want to grow in and learn what's required to do it, and never be afraid to pivot. The path you're on now, when I was 17, as soon as I picked chemical engineering, I was like, I'm going to work for 3M. I'm going to make all these new products. And now I work with NASA. I'm not upset about how that turned, but it's definitely you pivot throughout your career. You have to be open to the new opportunities, and you can't be afraid of failure. You can't be afraid of the challenges.
Where do you go from here?
Yeah, right. Where do you go?
Where do you go from here?
Right now, we're working on the full-scale system scale up, right? So we're working on what would be required to support a manned mission to Mars. So we're building full-scale systems. We're coupling them with other technologies to produce multiple types of fuels. We're also building a lunar fueling station that would produce hydrogen and other fuels from the ice that they find in the permanently shadowed regions of the moon. So lucky for me, my career just kind of keeps building on itself. But really, I don't know. When I got to sit there with my kids on launch, and I'm not gonna lie, you work on a program like the one I did for NASA, that was 80 to 100-hour weeks for 4 years. It was absolutely no joke whatsoever. And I had 2 small children at the time. And watching that get strapped to the top of a rocket, and then you're just praying that as Mr. Wood said, that all those other little components that people designed, maybe they all hold and the thing doesn't blow up on its way up. That was probably, I don't know how you beat that. I don't know that you can, but also it's the base for what we do now. It's the stepping stone for how we believe we can impact the renewable energy market for the world, right? Our main focus, while the NASA programs are definitely favorite pet projects, right? Like, I don't know how you get cooler than that, in my opinion. I'm sure other people have their equivalent. But now we get to take that technology and apply it here on Earth and take care of carbon dioxide waste streams and look at producing fuels that have no, tailpipe emissions, things like that. So we're heavily involved with the Department of Energy now. That's a really exciting path. But no, like when I go talk to my kids' school, like we just talk about NASA work. It's pretty much the coolest.
Well, I mean, what I heard in that though is maybe the next step is saving the planet.
Yeah, that's the main goal. That most NASA projects really just excel at expediting development of technologies for Earth. Like that's really a lot of even defense spending, right? Like when you're doing R&D for defense, when you're doing R&D for the Department of Energy, when you're doing R&D for NASA, most of those applications you then take and apply to something terrestrial. We still laugh that we have, right, like Martian applications and terrestrial applications, and that's a normal thing we say here at work. Didn't feel normal about 7 years ago, but here we are. But no, it's we're definitely looking at disrupting the fossil fuel economy. We've got big things in our sights. It's crazy.
All right, do you have any closing remarks, or we can let you get back to your hectic schedule?
I mean, I think it's awesome that that I had this opportunity to talk to you guys. I think, right, like your path forward, the work that I've heard about that you're already doing, those are the building blocks. That's how you really solidify your career. And like Mr. Wood said, I didn't have those opportunities. We had shop class, like I got to do woodworking and we could do like small engines and stuff like that, but there was no base level support until you picked that was your path. So I mean, I think it's really exciting that you guys get to test out if this is where your passions lie, if the things you're learning excite you. And I hope, for the sake of the fact that someday I'll be hiring you guys, I hope it does. I hope it drives you. Or maybe you'll be hiring me. Who knows?